Here I'm going to explain about the Lagrange's formula for interpolation, and also I'm going to solve some basic problems under the Lagrange's formula here. Okay, so basically the Lagrange's interpolation formula is applicable for both the equal and unequal intervals of x entries. As you already studied in a Newton forward and a backward, in that case the x entries are in equal intervals, and but in this method Lagrange's formula is applicable for both the equal intervals and unequal intervals here. Okay, let us move on to the statement of the Lagrange's formula. If y0 is equals to f of x0, y1 is equals to f of x1, y2 is equals to f of x2, so on up to yn is equals to f of xn, be a set of values of unknown function of a y is equals to f of x here. Consider unknown function y is equals to f of x, then the values of this function is given as a y0 is equals to f of x0, y1 is equals to f of x1, so on up to yn is equals to f of xn, where x entries are here x0, x1, x2, so on up to xn. So here x entries are need not be equal intervals. It may be equal intervals or it may not be unequal intervals here. Okay, so therefore Lagrange's formula is applicable for both equal and unequal entries of means unequal intervals of x entries here. Okay, so what is the formula for Lagrange's interpolation formula? See here, then this y is given as y equals to f of x is equals to, observe here, x minus x1, x minus x2, so on up to x minus xn divided by x0 minus x1, x0 minus x2, so on up to x0 minus xn. This whole term is multiplied with the y0 here. This whole term is multiplied with here y0. Okay, this whole term is multiplied with here y0 plus x minus x0, x minus x2, x minus x3, so on up to x minus xn whole divided by x1 minus x0, x1 minus x2, so on up to x1 minus xn whole term multiplied with the y1 plus x minus x0, x minus x1, x minus x3, so on up to x minus xn whole divided by x2 minus x0, x2 minus x1, x2 minus x3, so on up to x2 minus xn. This whole term is multiplied with the y2 plus so on up to nth term is given as x minus x0, x minus x1, so on up to x minus xn minus 1 whole divided by xn minus x0, xn minus x1, so on up to xn minus 1, and this whole term is multiplied with the y1 here. Okay, so you can observe here each and every term here. Observe the first term what we have here, x minus x1, x minus x2, so on up to x minus xn whole divided by x0 minus x1, x0 minus x2, so on up to x0 minus xn. This whole term is multiplied with the y0. Observe this term, the numerator does not have the factor x minus x0. Observe the numerator part here, the numerator does not have the factor x minus x0 in a term. And the denominator is such that wherever is x appears in the numerator is replaced by x0 in the denominator, and the first term is multiplied with the y0. Okay, I hope it is understand. Similarly, you can observe here second term also, x minus x0, x minus x2, x minus x3, so on up to x minus xn divided by x1 minus x0, x1 minus x2, so on up to x1 minus xn into y1 is there. Observe here, similarly the factor x minus x1 is missing in the numerator term. Yes, so there is no x minus x1 term in the numerator part, and the denominator is such that wherever is x appears in the numerator, that x is replaced by x1. That x is replaced by x1 in the denominator, and the second term is multiplied by here y1. First term is multiplied by y0, second term is multiplied by y1, third term is multiplied by y2. You can observe the third term also. The numerator does not have the factor here x minus x2. There is no x minus x2 term in the numerator. That is the missing term in the numerator. And the denominator is such that wherever is x appears in the numerator, wherever is x appears in the numerator, that x is replaced by here x2 in the denominator. Here also x0, x1, x3 so on up to xn as it is. But this x is replaced by x2 in the denominator, and this whole term is multiplied with the y2. So that the last term has, we observe from here that the last term contains here, there is no x minus xn term here. That x term in the numerator replaced as xn in the denominator, and the whole term is multiplied with the yn. So this is called as here Lagrange's formula for a interpolation. It is called as here Lagrange's interpolation formula. Okay, the formula goes like this. Here the value of x. Here the value of x may be given or may not be given. That depends upon a completely over on the given question. Okay, so now I am going to solve here two types of problems under the Lagrange's interpolation formula. And one more important point here. See here, in each and every terms, the factors x minus x1, x minus x2 so on up to x minus xn is there. Here also same case, x0 minus x1, x0 minus x2 so on up to x0 minus xn. So the number of these terms depends on the number of entries in the given table. Okay, the number of these terms depends upon the number of entries in the given table here. Once again, I will explain this point with one example, then it will be clear. So it is all about the Lagrange's formula for a interpolation. Okay, so in the next video, I am going to solve two types of problems under the Lagrange's. So it is all about the Lagrange's interpolation formula. Thank you.